Public key cryptography and cryptocurrency. Public key cryptography was invented in the 1970s and is a mathematical foundation for computer and information security. Since the invention of public key cryptography, several suitable mathematical functions, such as prime number exponentiation and elliptic curve multiplication, have been discovered. These mathematical functions are practically irreversible, meaning that they are easy to calculate in one direction and infeasible to calculate in the opposite direction. Based on these mathematical functions, cryptography enables the creation of digital secrets and unforgeable digital signatures. Bitcoin uses elliptic curve multiplication as the basis for its cryptography. In Bitcoin, we use public key cryptography to create a key pair that controls access to Bitcoin. The key pair consists of a private key and derive from it a unique public key. The public key is used to receive funds, and the private key is used to sign transactions to spend the funds. There is a mathematical relationship between the public and the private key that allows the private key to be used to generate signatures on messages. These signatures can be validated against the public key without revealing the private key. When spending Bitcoin, the current Bitcoin owner presents her public key and a signature, which is different each time but created from the same private key, in a transaction to spend those Bitcoin. Through the presentation of the public key and signature, everyone in the Bitcoin network can verify and accept the transaction as valid, confirming that the person transferring the Bitcoin owned them at the time of the transfer. Tip: in most wallet implementations, the private and public keys are stored together as a key pair for convenience. However, the public key can be calculated from the private key, so storing only the private key is also possible. Private and public keys. A Bitcoin wallet contains a collection of key pairs, each consisting of a private key and a public key. The private key, small k, is a number usually picked at random. From the private key, we use elliptic curve multiplication, a one-way cryptographic function, to generate a public key, bit K. From the public key, bit K, we use a one-way cryptographic hash function to generate a Bitcoin address, bit A. In this section, we will start with generating the private key, look at the elliptic curve math that is used to turn that into a public key, and finally, generate Bitcoin address from the public key. The relationship between private key, public key, and Bitcoin address is shown in the diagram below. Why use asymmetric cryptography? Why is asymmetric cryptography used in Bitcoin? It's not used to encrypt the transactions. Rather, the useful property of asymmetric cryptography is the ability to generate digital signatures. A private key can be applied to the digital footprint of a transaction to produce a numerical signature. The signature can only be produced by someone with knowledge of the private key. However, anyone with access to the public key and the transaction fingerprint can use them to verify the signature. This useful property of asymmetric cryptography makes it possible for anyone to verify every signature on every transaction, while ensuring that only the owners of private keys can produce valid signatures. Private keys. A private key is simply a number picked at random. Ownership and control over the private key is the root of user control over all funds associated with the corresponding Bitcoin address. The private key is used to create signatures that are required to spend Bitcoin by proving ownership of funds used in a transaction. The private key must remain secret at all times, because revealing it to third parties is equivalent to giving them control over the Bitcoin secured by that key. The private key must also be backed up and protected from accidental loss, because if it's lost, it cannot be recovered, and the funds secured by it are lost forever. Tip: the Bitcoin private key is just a number. You can pick your private keys randomly using just a coin, pencil, and paper. Toss a coin 256 times, and you have the binary digits of a random private key you can use in a Bitcoin wallet. The public key can then be generated from the private key. Generating a private key from a random number. The first and most important step in generating keys is to find a secure source of entropy, or randomness. Creating a Bitcoin key is essentially the same as pick a number between 1 and 2 to the 256th power. The exact method you use to pick that number does not matter, as long as it is not predictable or repeatable. Bitcoin software uses the underlying operating system's random number generators to produce 256 bits of entropy. Usually, the OS random number generator is initialized by a human source of randomness, which is why you may be asked to wiggle your mouse around for a few seconds. More precisely, the private key can be any number between 0 and n-1 inclusive, where n is 1.1578 times 10 to the 77th power, defined as the order of the elliptic curve used in Bitcoin. To create such a key, we randomly pick a 256-bit number and check that it is less than n. In programming terms, this is usually achieved by feeding a larger string of random bits collected from a cryptographically secure source of randomness into the SHA-256 hash algorithm, which will conveniently produce a 256-bit number. If the result is less than n, we have a suitable private key. Otherwise, we simply try again with another random number. Warning: do not write your own code to create a random number or use a simple random number generator offered by your programming language. Use a cryptographically secure pseudo-random number generator with a seed from a source of sufficient entropy. Study the documentation of the random number generator library you choose to make sure it is cryptographically secure. Correct implementation of the pseudo-random number generator is critical to the security of the keys. The following is a randomly generated private key shown in hexadecimal format: 1E99 ... AEDD. Tip: the size of Bitcoin's private key space, 2 to the 256 power, is an unfathomably large number. It is approximately 10 to the 77th power in decimal. For comparison, the visible universe is estimated to contain 10 to the 80th power of atoms. To generate a new key with the Bitcoin Core client, use the getNewAddress command. For security reasons, it displays the address only, not the private key. To ask Bitcoin D to expose the private key, use the dump private key command. The dump private key command shows the private key in a base 58 checksum encoded format called the wallet import format, WIF, which we'll examine in more detail in a future section. Here's an example of generating and displaying a private key using these two commands. $, Bitcoin-CLI, getNewAddress. $Bitcoin-CLI, dump private key, 1J7MD ... XYZ. The dump private key command opens the wallet and extracts the private key that was generated by the getNewAddress command. It is not possible for Bitcoin D to know the private key from the address unless they are both stored in the wallet. Tip: the dump private key command does not generate a private key from an address, as this is impossible. The command simply reviews the private key that is already known to the wallet, and which was generated by the getNewAddress command. You can also use the Bitcoin Explorer command line tool to generate and display private keys with the commands seed, ec-new and ec-2-wif. $bxseed, pipe, bxec-new, pipe, bxec-2-wif. Public keys. The public key is calculated from the private key using elliptic curve multiplication, which is irreversible. Big K equals small k times big G, where small k is the private key. Big G is a constant point called the generator point, and big K is the resulting public key. The reverse operation, calculating small k if you know big K, is as difficult as trying all possible values of small k, i.e. a brute force search. Before we demonstrate how to generate a public key from a private key, let's look at elliptic curve cryptography in a bit more detail. Tip: elliptic curve multiplication is a type of function that cryptographers call a one-way function. It is easy to do in one direction, and impossible to do in the reverse direction. The owner of the private key can easily create the public key and then share it with the world, knowing that no one can reverse the function and calculate the private key from the public key. This mathematical trick becomes the basis for unforgeable and secure digital signatures that prove ownership of Bitcoin funds.